Okay, so we have here problem number 6. Consider the roof truss below. The roof is simply supported on the purlins, which are attached to the joints of the top chord of the truss. So we have like here a simply supported truss, a pin at A and a ruler at D. If you encounter a problem like this, more or less this is a wind load because you have a pushing effect, and you on the other side you have a suction effect. Okay, because wind is blowing on one direction, so it is pushing on the other side and it is uh, suctioning on the other side. So if you encounter a problem like this, more or less we're going to be dealing it with respect to its tributary area or tributary length. But since we are just given the two dimension, we are going to consider the tributary length. But if we are given the three dimension, wherein we are given the length of the roof, then we can analyze it via its tributary area. But for this time, it is only the tributary length. When we say tributary length, we are going to consider half of the length of this span plus half of the length of this span, and that will be carried by this purlin. Okay, so this is a roof purlin. When we say purlin, it is the one that is transmitting the load from your GI sheet to your roof truss. Okay, so I repeat, your roof purlin is the one transmitting the load from the GI sheet to your roof truss. Okay, so since we have this uniformly distributed load, let's first convert it into its point load. And in doing so, we need to determine the length AE and AG. Okay, so we have here a length of 32 feet and a height of 24 feet. So from there, we can solve what we call an angle. So let's say this is angle theta. Okay, so tangent, tangent theta is equivalent to opposite over adjacent, and the opposite is 24 divided by the adjacent side of 32 feet. Theta therefore is equivalent to arctan of 24 over 32. Theta therefore is equivalent to tangent 24 over 32, and that is 36.87 degrees. Okay, so uh, length AE can be solved using the right triangle. And if we are to redraw this, that is length AE take note, this is a right triangle, and that is a 90-degree angle from there. So since that is 90-degree angle, we have here 25 feet, and yeah, 25 feet. Then we have there AE. So this is AE. Okay. Then we have here our theta, which is equivalent to 36.87 degrees. So what function can we use in order to solve for AE? So to solve for AE, we can use the cosine function. Cosine 3687 adjacent over hypotenuse. Okay? So cosine 36.87 is equivalent to AE over the hypotenuse of 25. So AE is equivalent to 25 cosine 36.87. So AE is equivalent to 19.999, or it is simply equivalent to 20 feet. Okay. Next would be AG. Okay. So for AG, if we are to redraw that, if we are to redraw our triangle, it would look like this. So we have here 24 feet, and we have here 32 feet, and this is our angle. The angle is equivalent to 36.87, and this is our AG. Okay, so we can use either sine or cosine function. So sine, if we are going to use sine function, sine 36.87 is equivalent to 24 over AG. And we have AG is equivalent to 24 over sine 36.87. AG therefore is equivalent to 24 over sine 36.87, and that is equivalent to 40 feet. Okay, so they have the same length. AE and EG has the same length. Okay, since we already know that, we can now redraw our our truss. Okay, so redrawing our truss, it would look like this. Okay, so it would look like this. Don't mind this, this is an erasure. So I am converting my uniformly distributed load into its equivalent point load. But the question is, how much will this purlins will carry? Okay, so what will happen is we will be using the tributary length. Okay, so half of this length from A to E will be carried by the purlin at A, half will be carried by E, and half of the length of EG will be carried by this purlin, and half would be carried by G. So if I am to divide the length, if I am to divide the length, take note that this is 20 feet, this is also 20 feet. By the way, this is perpendicular. All of them are perpendicular with respect to the roof. Okay, so this is 20 feet. So half of 20 feet, that is 10 feet. 10 feet would be carried by this. Then we have 10 feet of load, then 10 feet of load to the right, 10 feet of load to the left of this purlin, 10 feet of the load to the right of that purlin will be carried by this this purlin here at E. Then the half will be carried by this purlin. Okay, so we have a load of 250. So 250 so we have here 250 pound per feet. 250 pound per feet times the tributary length of A is 10. So times 10 feet, feet will cancel out, and that would be This is at A. That would be 250 times A times 10. That is 2,500 pounds. Okay. Now at E, the tributary length is 10 to the left and 10 to the right, because this half of 20 is 10, half of 20 is 10, so 10 to the left and 10 to the right. So the load is 250 pound per feet, times we have 10 plus 10, that is in feet. Feet will simply cancel out, therefore that is equivalent to 2,500 no 5,000 pounds. Okay, then for G, we have G on the left, we have uh, we have half tributary length. So the half of 20 feet is 10, so the tributary length is 10. So we have here 250 pounds per feet times 10 feet, and feet will simply cancel out, therefore that is 2,500 pounds. Next would be the G on the left side, right side. So G on the right is equivalent to, we have here 125. Okay, so 125 pound per feet times the tributary length. So this length here is the same, this is 20 feet, so divided by 2, that would be 10. The tributary length of G to the right is 10, so times 10 feet, cancel the feet, so that is equivalent to 1,250 pounds. Okay, next would be on the F. So for the F, it is tributary length again, half of this is 10 feet, half of 20 feet is 10, so 10 to the left, 10 to the right, that is 20, and it is 125. So 125 pound per feet times 10 plus 10 feet is equivalent to 2,500. Okay, so 2,500 pounds. And lastly, we have here the at D. So D, we have the tributary length. It only has the length on the left, and the half of that length, which is 20, is 10. So it is only 10. So 125 pound per feet times 10 feet, cancel, it is 1,250 pounds. So we're going to plug in these values into our truss. So I redraw here the truss, and what we're going to do is to plug in these values. So at A, it is 2,500 pounds. At E, it is 5,000 pounds. At G, on the left, it is 2,500 pounds. At G to the right, it is 1,250 pounds. At F on the right, it is 2,500 pounds. And at D on the right, it is 1,250 pounds. Okay, so we have here a vertical, assume direction to be upward, a horizontal, assume direction to be pointing to the left, and D vertical is assumed direction pointing upwards. Okay, so what we need to do is to determine the forces on all of the members. So determine the forces on each member. So if we are to determine the forces on each of these member, it is best to use the method of joints. Because if we're going to use the method of sections, we will be method of section that will be more procedural, because take note, we have 1 2 3 4 5 6 7 8. Wait, 1 2 3 4 5 6 7 8 9 10 11. We have 11 members, so you need to cut here and there. So if we're going to use the method of joints, we can draw the joints of each of these truss, and that would be more practical. So before determining the forces on each bar, we need first to solve for the reaction. When we say reaction, it is the reaction of this the support with respect to the applied external loading. Okay, so it will be divided into these two supports. Okay, to determine the reaction, let's start at point A. So summation of all forces, summation of moment of all forces rotating at point A, we can solve for the vertical. So summation of moment with respect to A is equivalent to 0. All forces that are rotating clockwise should be positive. So what are those forces? So we have here 2, 5 that will cancel out because it is concurrent with A. Next, we have here 5,000 pounds. 5,000 pounds is 20 feet from A, and it is rotating in a clockwise manner. So 5,000 times a lever arm of 20. Next, we have the 2,500. So the 2,500 is also rotating in a clockwise manner, plus 2,500 times a lever arm of 40 feet. Now for 1,200, 2,500, and 1,250, we can it is not the same as 40 and 20. So what we're going to do is to determine the vertical and horizontal distances. Okay, so why not kunin na natin yung kanilang mga horizontal and vertical components. So let's solve the vertical and horizontal components together with their distances. So we have here take note that the slope here is we have 24 over 32. So that is 24 over 32. We have 3 over 4. So 3 for the vertical, 4 for the horizontal. So 3, 4, that is the square root of 5. Since these loads are perpendicular to our contact surface, then we can say that the slope of this load is 3 vertical, horizontal, 4 vertical, and the square root of 5. So they will interchange. Okay, so we have here alpha x times, let's start with the horizontal. The horizontal is 3 over the square root of 5, over 5, which is the hypotenuse. So calculate, we have here 2,500. That is 1,500, 5,000, that is 3,000, and we have here 2,500 again, that is 1,500. Next is 1,250, and that is 750. Next, we have 2,500. That is 1,500. And the horizontal component of 1, 2 is 750. Now, for the vertical naman, we have alpha x times 4, which is the vertical component of the slope over the hypotenuse of 5. So calculate. We have 2,500. That is 2,000. For 5,000, we have naman 4,000. And this is 2,500, so that is 2,000. Next, we have 1,250. This is 1,000. And next, we have here 2,500. So that is 2,000. And this is also 1,000. Okay. So we need to determine the distance. So how are we going to do that? Let's solve for distance. So from here, if we are to redraw our triangle, this is our triangle there. You have here 30, what is that? 36, what is the angle? Ayun, 36.87. Let's say this is x1. And our AE is 20 feet. Okay, so we're going to use cosine. So cosine 36.87 is equivalent to x1 over 20. So x1 is equivalent to cross multiply 20 cosine 36.87. So x1 is equivalent to 16 feet. Okay, so that is 16 feet. So this distance here to A is 16 feet. So we this is 9 feet because that is 25. Okay, so we have here the distances. So 9 feet. Then we have 14 feet, or we have here 7 feet, 9 feet, and 16 feet. So our diagram is now complete. Okay, so we're already done with the 5,000 and the 2,500. So we can now continue with the 1,000. 1,000 is going to rotate in a counterclockwise manner. So we have minus 1,000 times a lever arm of 7 plus 9 plus 16, 25 plus 7, 32. So that is 32. Then we have 750 rotating in a clockwise, so plus 750 times a lever arm of, take note, this is 24 feet because this is 12 feet, 12 feet. So 750 times 24. Next, we have 2,000 rotating counterclockwise times a lever arm of, we have 9 plus 14 plus 25, 48. So times 48. Next, the 1,500 would be rotating clockwise. So 1,500 times a lever arm of 12. And lastly, we have the 1,000 rotating in a clockwise manner. So it would rotate in a clockwise manner, counterclockwise manner rather. So 1,000 times a lever arm of 25 plus 25 plus 14. So that is 62 feet and equate it to 0. 750 will not rotate because it is concurrent with point A. I repeat, we can use naman the 1,250, the 25, and the 1,250 directly. It's just that we're going to get the perpendicular distance with respect to A, and that would be a matrabaho. So it's best if we can just convert them to vertical and horizontal component. Okay? And lastly, we forgot the vertical. The vertical rotating counterclockwise, so that is negative. The vertical times a lever arm of 62, and equate that to 0. The vertical therefore is equivalent to 5,000 times 20 plus 25 times 40 minus 1,000 times 32 plus 750 times 24 minus 2,000 times 48 plus 1,500 times 12 minus 1,000 times 62 minus alpha x times 62, and that is equivalent to the vertical is 741.94 pounds. Since we already have our d vertical, we can now solve for our a vertical. So that would be summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So I have here a vertical. My assumed direction is upward. So that is plus minus 2,000 minus 4,000 minus 2,000 plus 1,000 plus 2,000 plus 1,000 plus the vertical of 741.94 equate that to 0. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2,000 and 2,000 will cancel out. 1,000 plus 1,000, that's 2,000 minus 2,000, it will cancel out. So a vertical is equivalent to minus 4,000 plus 741.94 equated to 0. Wait, are we missing something? Okay, so we have an error here. The total distance here is 16 plus 9 plus 14 plus 9 plus 16 is 64, not 62. Okay, so that is 64. Therefore, the vertical is, so dv here is 687.5 pounds. So let's change it here. So we have here 687.5 pounds. Okay, so A here would be quite big because let's first solve for the AV. Alpha x minus 4,000 plus 687.5 is equivalent to 0. That's equivalent to 3,312.5 pounds. AV here would be quite big because if you're going to see, if you're going to observe, the forces here are towards right. Okay, so it is towards right, but the forces on the right side is suctioning, or it is pulling. So it is helping in supporting D. That's why A is carrying more load compared to support D. That's why A is 3,312.5 while D is 687.5 because the suction is pulling in the support of D. But if there is no suction, like for example, it is a compression force, because this one is a tension force. If this is a compression force, we can see, or we can say by solving likewise that the value of a vertical and d vertical will not be that far. But since this is the case here, AV will be carrying more load. Okay, so we now have our A vertical and D vertical. We can now solve for our A horizontal. So A horizontal, summation of forces horizontal is equivalent to 0. All forces that are pointing towards right should be positive. So by observation, almost all or all of the horizontal force are towards right. So my assumed direction for A horizontal is towards left. So A horizontal negative plus 1,500 plus 3,000 plus 1,500 plus 750 plus 1,500 plus 750. Equate that to 0. A horizontal therefore is equivalent to 1,500 plus 3,000 plus 1,500 plus 750 plus 1,500 plus 750 is equivalent to 9,000 pounds. Okay, so we can now solve for the forces of each of members. So let's start with AB. So FBD, so free body diagram of joint joint A. So that for that joint A, let's just draw our free body diagram. So what are the forces present at joint A? So the force present, we have the A vertical. We have here 3,312.5. Then we have the A horizontal. A horizontal is 9,000. Next we have the 1,500 towards the right. So we have here 1,500. Then we have the downward force of 2,000. Then we have here member. This is member AB. So there you have their member AB and you have their AE. So member AE. And the slope here is, that is 3, 4, and 5. Okay, so it is better if we're going to solve for the vertical first because we will be only having one known and one unknown. But if we're going to solve for the horizontal first, we're going to have two unknowns. Okay, so summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? So we have here negative 2,000 plus 3,312.5 plus AE. It is better for all forces, for all the members, we are going to assume in tension. Okay, so if the answer would come out as negative, then our assumed direction is opposite, is incorrect, and we need to change it to otherwise. Okay, so my assumed direction here is in tension. So AE times the vertical component of the slope, which is 3 over the hypotenuse of 5, and equate it to 0. So we have here negative 2,000, 2,000 plus 3,312.5 plus alpha x times 3 over 5, equate it to 0, and AE is equivalent to negative. Okay, so it is negative 2,187.5. Okay, so my assumed direction here is incorrect, so it is in compression. So AE is equivalent to 2,187.5, and that is in pounds, and it is compression. Okay. For AB, we have summation of forces horizontal is equivalent to 0. All forces towards right should be positive. So what are those forces? So we have negative 2,000 plus, no, not 2,000. We have 9,000. Negative 9,000 plus 1,500 plus what is AE? We have, we have negative, because it is compression, negative 2,187.5 times the horizontal component of 4 over the hypotenuse of 5. And my assumed direction for AB is tension, so that is positive, plus AB equals 0. So we have negative 9,000 plus 1,500 minus 2187.5 times 4 over 5 plus alpha x is equivalent to 0. AB is equivalent to 9,250 pounds, and it is in tension. Okay. Next would be joint B, or let's say joint E. So we have here the free body diagram. The FBD of joint E. So the free body diagram of joint E. So this is joint E. What are the forces present? So the forces present, or the members present, we have 4,000. A downward force of 4,000. So this is joint E, this is joint A. 4,000. Then we have here a horizontal force of 3,000. Next, we have AE. What is AE? It is in compression. So, kung dito pababa, dito pataas. Okay? So, this is 2,000 AE. 2,187.5. Next, we have here joint BE. Again, I'll assume it to be in tension. So we have here BE, and the slope of BE, if this is 4/3, 3, 4, 5. The slope of BE, since it is concurrent, collinear with force at E, it is opposite. So 4 vertical, 3 horizontal, the square root of 5. Then we have here EG. So for EG, again, I'll assume it in tension. So this is EG, and the slope is 4 horizontal, 3 vertical, and the hypotenuse of 5. Okay? So summation of forces horizontal is equivalent to 0. All forces towards right should be positive. So what are those forces? So we have 3,000, that is positive. Okay? Then we have here plus 2,187.5 times the horizontal component of 4 over the square root of 5, plus we have here EG. So EG times the horizontal component of 4 over the square root of 5, plus BE times the horizontal component of 3 over the square root of 5 is equivalent to 0. So this is my equation number 1. Now, for equation number 2, we can simplify this, but if you are in a hurry and the solution is not that needed, then we can just simply input that in your calculator. But if the solution is needed, like for example complete solution, then simplify this in terms of the other. Okay, summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So we have 2,187.5 times the vertical component, which is 3 over 5. 3 over 5. Then we have minus 4,000 plus we have EG times the vertical component of 3 over 5. Then we have here BE. It is pointing downward, so that is minus BE times the vertical component of 4 over the square root of 5. So we have 1, 2, 3, 4. 1, 2, 3, 4. And equate it to 0. And this is my second equation. Okay? So we have here, solve it simultaneously. Two unknowns. EG is 4 over 5. BE is 3 over 5. Then negative 3,000 minus 2187.5 times 4 over 5. Then we have here 3 divided by 5. We have here 4 divided by 5. No. This is negative 0.6, negative 0.8. No. EG is positive 0.6. BE is negative. Then here we have 4,000 minus 2187.5 times 3 over 5. Okay. Solving. EG is equivalent to negative 2,187.5, and it pounds. It is in compression because it is negative, so that is equivalent to 2187.5, and it is in compression. Then we have what's that? BE. BE is equivalent to negative 5,000. So again, it is in compression. So we have 5,000 pounds, and that is in compression. If you're going to check it here, the load here is to compression towards, or compressing towards the joint. Therefore, the counter or the reaction would also to counter that force, and more or less it would be compression. So it is correct. Okay. So likewise here, the force here is compression towards the joint. Therefore, the counter would also be in compression. That's why it is compression. Okay. Next would be the free body diagram. FBD of joint, let's say B. Okay. So we have here joint B. This is joint B. Okay. So we draw the free body diagram of joint B. So what are the forces present at joint B? We have BE. So BE here is compression. So that is compression. That is also compression. So if it is towards the joint, this time it is also towards the joint again. Okay, so we have there BE plus we have AB. AB is tension. So it is towards this point. AB is equivalent to 9,250. Then this is equivalent to BE 5,000 pounds. Then we have here, okay, I'll assume it to be in tension. Then I have here BC. So this is BC and this is BG. Okay, so the slope here is 7 is to 24. So we have 7, 24. So that's it. 7, 24. And the hypotenuse is 7 squared plus 24 squared, 25. So we have 25. Okay, so that is our hypotenuse. So we can now solve summation of forces vertical. So let's start with vertical. So we will only have one unknown. So summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? We have 5,000 and the slope of that is 4. So we have it as 4 vertical, 3 horizontal, and 5 as the hypotenuse. So for the vertical, it is pointing downwards. So negative 5,000 times the vertical component of the slope, which is 4, over the hypotenuse of 5. Then BG is assumed to be upwards. So that is plus BG. So we have here BG times the vertical component of the slope, 24, over the hypotenuse of 25, and equate that to 0. BG therefore is equivalent to negative 5,000 times 4 over 5 plus alpha x times 24 over 25 is equivalent to 0. BG is 4,166.67 pounds and it is in tension because our angle, our sign is positive. Okay, so are we sure with our slope? 7 squared plus 24 squared. Yes, it's 25. Okay, next would be the horizontal. Okay, so that is BC. Summation of forces horizontal is equivalent to 0. All forces towards right should be positive. So what are those forces? We have negative 9,250 plus BC plus 5,000 times the horizontal component of 3 over the hypotenuse of 5 plus BG. What is BG? 4,166.67 times the horizontal component of 7 over the hypotenuse of 25, equate that to 0. So 9,250 plus alpha x plus 5,000 times 3 over 5 plus 4,166.67 times 7 over the 25, equate that to 0. And that is equivalent to BC. C is equivalent to, we have negative 9,250 plus alpha x plus 5,000 times 3 over 5 plus 4,166.67 times 7 over 25 is equivalent to 0. Shift solve. Therefore, BC is equivalent to 5083.33, and that is in tension. Okay, so we can now solve for, let's say we have G. So for G, we have here the free body diagram of joint G. Okay, so for the free body diagram of joint G, what are the forces present at joint G, we have here a downward force of 2,000, an upward force of 1,000, a force towards right which is 1,500, then a force towards right again which is 2,750 rather, okay, 750. So 2,000, 1,000, 1,500, 750. Then we have here member EG. Member EG from our previous solution is compression, 2,187. So it is towards the joint since it is compression, 2,187.5. Okay. So 2,187.5, and it has a slope of 3 vertical, 4 horizontal. 3 yeah, 3 vertical. This is EG. So 3 for the square root of 5. And we also have here joint G BG. So we also have here BG. So BG, I think it is in compression. BG, where's BG? BG, no, it is in tension. So BG here is in tension, and that is 4,166.67. The slope here is, you have 7 horizontal, 24 vertical, and the hypotenuse of 25. Okay, so are we sure here with our BG? So what member is this? 5,000. So BE is compression. So BE, so yeah, so that is in compression. So that is downward force. Okay, so we're correct. Now we have here GF and CG. So we have, I'll be assuming it again to be in tension. This is member GF, and this is member CG. So GF here has a slope of 3 vertical, 4 horizontal, hypotenuse of 5. Then for CG, we have 7, 24, 25. So we have the summation of forces. Vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? We have 1,000 and it is pointing upwards. So 1,000 minus 2,000 plus 2,187.5 times the vertical component of 3 over the hypotenuse of 5 minus 4,166.67 times the vertical component of 24 over the hypotenuse of 25 minus CG. So minus CG times the vertical component of the slope, which is 24 over the hypotenuse of 25, minus GF times the vertical component of the slope, which is 3 over the hypotenuse of 5, is equivalent to 0. So this is my first equation. Okay. So next is the summation of forces horizontal. Summation of forces horizontal is equivalent to 0. All forces that are pointing towards right should be positive. So what are those forces? We have here 1,500 plus 750 plus we have 2,187.5 times the horizontal component of the slope, which is 3 over the hypotenuse of 5, minus 4,166.67 times the horizontal component of the slope, which is 7 over the hypotenuse of 25. Okay? And then we have here plus, unahin natin si CG. We have CG times the horizontal component of the slope, which is 7 over the hypotenuse of 25, plus GF times the horizontal component of the slope, which is 4 over the hypotenuse of 5, is equivalent to 0. And this is my equation number 2. So input that in your calculator. We will be having we have two unknowns. So we have negative CG of 24 divided by 25, and we have GF of 3 divided by 5, negative 3. Then we have here, transpose this to the other side of the equation, that is 1000. Yeah. So negative 24 divided by 25, negative 3 divided by 5, then negative 1000 plus 2000 minus 2187.5 times 3 divided by 5 plus 4166.67. Then for our second equation, we have CG 7 divided by 25, GF 4 divided by 5, then negative 1500 minus 750 minus 2187.5 times 3 divided by 5 plus 4166.67 times 7 divided by 25. And X is equivalent to, and that is CG. CG is equivalent to negative 2,743.06 pounds, and Y, that is GF. GF is equivalent to negative 2,034.72 pounds. That is equivalent to 2,743.06 pounds, and that is in compression. This is 2,034.72 pounds, and that is again in compression. So we already have here CG, we have GF, CG, and yeah. So let's now proceed with D. So we can solve CD, and we can solve for F. Okay. Actually, we can start with either of these three, because we will be left with one unknown. If I'm going to start here, I'll be solving this. This is unknown. If I'm going to solve this, I can solve this too. This is unknown. Okay. So let's start with at point D. Okay. So FBD of joint D. So the free body diagram of D is equivalent to, drawing the joint D, we have there this. So this is joint D. So what are the forces present at joint D? So we have here 750. We have here an upward force of 1000. We have here a reaction, D vertical, and D vertical is 687.5. And we have here CD. So I am going to assume that CD is a tension. So this is CD. Then I also have here DF. Okay, so this is DF. The slope of DF is 3 vertical, 4 horizontal, 5 hypotenuse. Okay, so summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those forces? So we have 1000 plus 687.5 plus df, because I assume it to be in tension, times the vertical component of 3 over the hypotenuse of 5 is equivalent to 0. So more or less, this will become negative. So 1000 plus 687.5 plus alpha x times 3 over 5. 3 over 5, equate that to 0. df is equivalent to negative 2,812.5 pounds, and that is equivalent to 2,812.5 pounds, and that is in compression. Okay, lastly, for the horizontal, for CD, we have summation of forces horizontal is equivalent to 0. All forces that are pointing to the right should be positive. So we have here negative CD. This should be compression. So we have there, what is df? It is towards right, therefore it is positive, plus 2,812.5 times the horizontal component of 4 over the hypotenuse of 5 plus 750 is equivalent to 0. Therefore, CD is equivalent to negative plus 2812.5 times 4 over 5 plus 750 is equivalent to 0. CD therefore is equivalent to 3,000 pounds, and that is in tension. Okay, and lastly we have joint C, or let's say joint F. FBD of joint F. We have, yeah, joint F, so we can solve for C. So FBD of joint F. So draw the free body diagram. So what are the forces present? So we have here 2,000. We have here 1,500. Then we have here the GF. Yeah, we have GF, and we also have DF. So GF, what is GF? Where's GF? GF is 2,034, and that is in compression. So we have here 2034.72, that is in compression. The slope is 3 vertical, 4 horizontal over the hypotenuse of 5. Then we have DF. DF here, it is also in compression, and that is equivalent to 2,812.5, and the slope here is 3 vertical, 4 horizontal, 5 hypotenuse. Okay, and lastly we have member, this is member CF. Okay, member CF, and the slope is 4 vertical, 3 horizontal, the hypotenuse of 5. Okay, so summation of forces, let's say vertical 1 1 2 3 4, pag horizontal 1 2 3 4, they're the same. Summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those? So we have negative 2034.72 times the vertical component of the slope, which is 3 over the hypotenuse of 5, plus we have CF times the vertical component of the slope, which is 4 over the hypotenuse of 5, plus we have 2,812.5 times the vertical component of the slope, which is 3 over the hypotenuse of 5, plus 2,000, equate that to 0. So negative 2034.72 times 3 over 5 plus alpha x times 4 over 5 plus 2812.5 times 3 over 5 plus 2,000 is equivalent to 0. Shift solve. And CF is equivalent to negative 3,083.34 pounds. And that is equivalent to 3,083.34 pounds. And that is in compression. So my assumed direction here is, that is in tension. No. It is not in compression. It is in tension because my assumed direction here is compression. But since it became negative, then the direction is otherwise. Therefore, it is in tension. So we were able to solve for all the forces. So what we're going to do next is to summarize. So summarizing, we have here the members and we have here the members. We have here the forces and we have here the direction. Compression, tension, tension, compression, and so on. Okay, so just double check it. We might be able to have an incorrect value due to wrong input in the calculator, but the process is correct. Okay.